Hello dear students, in this video I'll continue with revision for CBSE board examination. In this video I'll solve the questions from the exercises of chapter 1 numbers, quantification and numerical applications from the CBSE handbook. So these are the questions from the first exercise of CBSE handbook. All the questions in the first exercise are pertaining to the topic modular arithmetic and congruence modulo. The first question, find the sum of 132 and 121 mod 23. So here we have to find 132 plus 121 mod 23. Now we are aware of the addition property in modulo arithmetic. According to that property, this is equal to 132 mod 23 plus 121 mod 23 mod 23. This is using the addition property. Since a plus b mod m equal to a mod m plus b mod m plus, b mod m mod m. So this is equal to, here 132 mod 23. When we divide 132 by 23, we get the remainder as 17. So this is 17 plus 121 mod 23. When we divide 121 by 23, we get the remainder as 6. So it is 17 plus 6 mod 23. So this is 23 mod 23. When we divide 23 by 23, we will get the remainder as 0. So the sum of 132 and 121 mod 23 is 0. Moving on to the next question. Find 7 raised to 6 mod 3. Now if we consider 7 is congruent to 1 mod 3. According to the definition of congruence modulo, if a is congruent to b mod m, then a minus b is divisible by m. Here we have 7 congruent to 1 mod 3. Because 7 minus 1 equal to 6, it is divisible by 3. So from this we can write 7 raised to 6 congruent to 1 raised to 6 mod 3. So using the property, if a congruent to b mod m, then a raised to k congruent to b raised to k mod m, where k is any positive integer. So using this same property, if 7 congruent to 1 mod 3, then 7 raised to 6 congruent to 1 raised to 6 mod 3. Or we get 7 raised to 6 congruent to 1 mod 3. And according to the property of congruence modulo, if a congruent to b mod m, then a mod m will be equal to b mod m. So this implies 7 raised to 6 mod 3 is equal to 1 mod 3. 1 mod 3 is nothing but it is 1 itself. If this number is less than this number, then here we have 1 mod 3. It is equal to 1. Therefore, 7 raised to 6 mod 3 equal to 1. That is, when we divide 7 raised to 6 by 3, we will get the remainder as 1. Moving on to the next question. Find the value of x given that x congruent to 23 mod 27 if 21 less than or equal to x less than 31. So here we have to find the value of x if x is congruent to 23 mod 7 and x lies between 21 and 31. X congruent to 23 mod 7 implies x minus 23 is divisible by 7 by the definition of congruence modulo. So what value of x when substituted here will be divisible by 7? So if we substitute 21, 22, 23 up to etc. and so on, when we substitute x as 30, 30 minus 23 equal to 7 is divisible by 7. Therefore, x. Similar questions can be expected in multiple choice questions for 1 mark. Let us continue. Find the remainder when 226 into 369 into 122 into 461 into 1025 is divided by 8. So we have to find, this is nothing but we have to find 226 into 369 into 122 into 461 into 1025 mod 8. If we find mod 8, we will know the remainder when we multiply all these and divide by 8. So using the multiplication property of modulo arithmetic, this is equal to 226 mod 8 into 369 mod 8 into 122 mod 8 into 461 mod 8 into 1025 mod 8 mod 8. Now when we divide 226 by 8, we get the remainder as 226 divided by 8. We get the remainder as 2. So this is 2. Next, when we divide 369 by 8, we get the remainder as 1. So this is 1. Next, when we divide 122 by 8, we get the remainder as 2. So 122 mod 8 is 2. When we divide 461 by 8, we get the remainder as 5. So it is 5. When we divide 1025 by 8, we get the remainder as 1 because 1024 is divisible by 8. So the remainder is 1. When we multiply all these, it is 20 mod 8. When we divide 20 by 8, we will get the remainder as 4. So the remainder when this term is divided by 8 is 4. Next question, evaluate 16 into 29 mod 7. So this is very easy. We have only these two numbers. So 16 into 29 mod 7 is 16 mod 7 into 29 mod 7. When we divide 16 by 7, we get the remainder as 2. And when we divide 29 by 7, we get the remainder as 1. Mod 7. So it is 2 mod 7. When we divide 2 by 7, it is 0 times 7. So it is 2 itself. So that is the reason why if we have A mod B and if A is less than B, then we get A mod B as A itself. So this is equal to 2. Let us continue. if x mod 9 equal to 2, find all the possible values of x where 0 less than x less than 47. So here it is given when x is divided by 9, the remainder is 2. We have to find all possible values of x where x lies between 0 and 47. So this is nothing but this is equivalence class of 2. It is nothing but set of all a belongs to z such that 0 less than a less than 47 and a congruent to 2 mod 9. So here all possible values of x is nothing but it is the equivalence class of 2. So here in this interval 0 to 47, if we consider the first number 2, 2 mod 9 is 2. Then the second number will be 2 plus 9. So 11 mod 9, it is 2. Then the next number will be 11 plus 9. 20 mod 9, it is 2. The next number will be 20 plus 9. 29 mod 9, it is 2. Then the next number is 29 plus 9, 38. 38 mod 9 is 2. The next number is 38 plus 9, which is 47. But 47, it does not lie in this interval because x varies from 0 to 47 but less than 47. So we do not have 47. So the equivalence class of 2, it is nothing but 2, 11, 20, 29 and 38. So this is equal to 2, 11, 20, 29 and 38. So these are the various possible values of x. Moving on to the next question. Find the positive integers less than 50 forming the equivalence class 4 for modulo 6. So we have to find all those positive integers which are less than 50 and it forms the equivalence class of 4 for modulo 6. So equivalence class of 4 is set of all a belong to the set of positive integers such that a less than 50 and a congruent to 4 mod 6. So this is nothing but all those numbers which are less than 50 and which when divided by 6 will give the remainder as 4. So the first number that will give the remainder 4 is 4 itself. The next number which when divided by 6 will give the remainder 4 is 4 plus 6, 10. The next number which will give the remainder 4 when divided by 6 is 10 plus 6, 16. Then the next number is 16 plus 6, 22. The next number is 22 plus 6, 28. Then we have 28 plus 6, 34. Then 34 plus 6, 40. Then 40 plus 6, 46. The next number is 46 plus 6, 52. But here we have those positive integers less than 50. So we do not have 52. It stops with 46. So this is the equivalence class of 4 for modulo 6. Next question, what time will it be after 200 hours if the present time is 5 am? So we have to find the time 200 hours after 5 am. So let us find the remainder when 200 is divided by 24. So in that case we will get the number of hours after 5 am in 24 hours format and then we can find the time accordingly. So 200 mod 24 it is equal to, when we divide 200 by 24, we get the remainder as 8. So 200 mod 24 is 8. Therefore, this 200 hours, it is nothing but 8 days, 8 hours. So if we start from 5 a.m., 8 days after 5 a.m. will be 5 a.m. So 200 hours after 5 a.m. will be equivalent to 8 hours after 5 a.m. 200 hours after 5 a.m. equal to 8 hours after 5 a.m. So if it is 8 hours after 5 a.m., then it is 13 hours. Now this 13 hours, it is nothing but it is 1 p.m. If we convert this into 24 hours format, we will get this as 1300 hours. That is 8 hours after 5 a.m., which is 1 p.m. So the answer is 1 p.m. The next question, there are 81 boxes with 21 articles in each. When we rearrange all of the articles so that each box has 5 articles, how many articles will be left without a box? So here there are 81 boxes with 21 articles in each. So the total number of articles is 81 into 21. So total number of articles is 81 into 21. Now we are rearranging them so that each box has 5 articles. So the number of articles that will be left, it will be given by 81 into 21 mod 5. Number of articles left out, it will be 81 into 21 mod 5. So it is 81 mod 5 into 21 mod 5 mod 5. Here when we divide 81 by 5, we get the remainder as 1, and when we divide 21 by 5, we get the remainder again as 1. So this is 1 mod 5. Here we can see that 1 is less than 5, so 1 mod 5 is equal to 1. As a result, one article, it will be left out. One article will be left out without a box. Next question, find 3 raised to 128 mod 7. So here again we have to use the property of modulo arithmetic. So let us start with, consider 9. 9 is 3 square. This 3 square, it is congruent to 2 mod 7. So when we divide 9 by 7, we get the remainder as 2, or if we see this, here 9 minus 2 is 7, 7 is divisible by 7. Now 3 square, the whole cube, it is congruent to 2 cube mod 7. 3 square, the whole cube is 3 raised to 6. 3 raised to 6 is congruent to 8 mod 7. If 3 raised to 6 is congruent to 8 mod 7, then we have 3 raised to 6 mod 7 equal to 8 mod 7. But 8 mod 7 is equal to 1. So this implies 3 raised to 6 congruent to 1 mod 7. Now we need 3 raised to 128. So this 3 raised to 128, we can write it as 3 raised to 126 into 3 square. So here what happens is 3 raised to 6, the whole raised to 21 will be congruent to 1 raised to 21 mod 7. This is using the property if A congruent to B mod M, A raised to K congruent to B raised to K mod M. It is using this property. So from this we get 3 raised to 126 congruent to 1 mod 7. So we have got up to this 3 raised to 126. We need 3 raised to 128. So from this we get 3 raised to 126 mod 7 is equal to 1. Therefore, 3 raised to 128 mod 7, it is equal to 1 into 9 mod 7. So 9 mod 7 is 2. So this is 2. Therefore, 3 raised to 128 mod 7, it is equal to 2. So when we divide 328 by 7, we will get the remainder as 2. So these are the various questions from the first exercise, which is on modulo arithmetic and congruence modulo. Now let us move on to the exercise on alligation and mixture. That is the third exercise. The first question, in what ratio must rice at rupees 69 per kg be mixed with rice at rupees 100 per kg so that the mixture be worth rupees 80 per kg? So here this is the cost of the cheaper ingredient and this is the cost of the dearer ingredient, and the cost of the mixture is given as rupees 80. This is the mean price. So the cost of cheaper ingredient is rupees 69, dearer ingredient is rupees 100 and the mean price is rupees 80. So let us use the rule of alligation here. So here C is 69, D is 100, M is 80. So here we have D minus M, it is 100 minus 80 which is 20, and here we have M minus C, it is 80 minus 69 which is 11. So the ratio in which these two rice should be mixed is 20:11. Therefore, cheaper ingredient is to dearer ingredient equal to 20:11. So this is the required ratio in which the two rice should be mixed. The next question, the average salary per head of the entire staff of a small factory including the supervisor and laborers is rupees 5,750. The average salary per head of the supervisor is 20,000 and that of laborer is rupees 5,000. Find the number of laborers in the factory if there are 4 supervisors. So here we can see that the salary for supervisor is higher, it is rupees 20,000, and the salary for laborers it is lower, which is rupees 5,000. The average salary for supervisors and laborers it is rupees 5,750. So here using C as rupees 5,000 and D as rupees 20,000, we have the mean salary M as rupees 5,750. We will be able to find the ratio of laborers to supervisors, and using that ratio we can find the number of laborers when there are 4 supervisors. So this is for laborers and this is for supervisors. This is the labor side and this is the supervisors side. So here we have D minus M. So here it is 20,000 minus 5,750. 20,000 minus 5,750. It is 14,250. And here we have M minus C, which is 5,750 minus 5,000. It is 750. So the ratio of laborers to supervisors is to supervisors. It is 14,250 is to 750. 14,250 is to 750. Or this is 14,250 upon 750. This is 19, or it is 19 by 1. So the ratio of laborers to supervisors is 19 is to 1. So for every 19 laborers, there is one supervisor. Here the number of supervisors is 4. Therefore, the number of laborers will be 19 into 4. Therefore, number of laborers, it is 19 into 4, which is 76. So this is the number of laborers. Moving on to the next question. A container contains 70 liters of orange squash. The squash being too concentrated, 7 liters of squash was taken out from this container and replaced by water. This process was repeated thrice to reduce the concentration of squash. How much quantity of orange squash is left in the container? So this is finding the original liquid which is left in the container. So here the original liquid was 70 liters. Then 7 liters of squash was taken out and replaced by water, and this process was repeated thrice to reduce the concentration of squash. So here we need to find the quantity of orange squash which is left in the container. So here X is 70 liters. Y, that is the quantity of original liquid which is taken out. It is 7 liters. And N is the number of times this process is repeated. It is 3. So quantity of orange squash left, it is equal to X into 1 minus Y by X the whole raised to N. So here X is 70 into 1 minus 7 by 70 the whole cube. So this is 70 into 1 minus 1 by 10 the whole cube. This 1 minus 1 by 10 LCM is 10, so it is 10 minus 1 9 by 10. 70 into 9 by 10 the whole cube. So this is 70 into 9 cube is 729 and 10 cube is 1000. So this is 51.03 liters. The quantity of orange squash which is left in the container, it is 51.03 liters. Moving on to the next question. Cost of two types of pulses is rupees 55 per kg and rupees 90 per kg. If both the pulses are mixed together in the ratio 2:3, what should be the price of the mixed variety of pulses per kg? So here the cost of cheaper quantity, it is given, the cheaper ingredient it is given, it is rupees 55, and the cost price of the dairy ingredient it is given rupees 90. We have to find M. So here we have D minus M and here we have M minus C. This ratio D minus M is to M minus C. We have this ratio given as 2:3. So using that we can find M. Cheaper quantity upon dearer quantity, it is nothing but D minus M upon M minus C. This ratio is given as 2:3, which is 2 by 3. This is equal to D is 90, 90 minus M upon M minus 55. So from this we can find M. Two M minus 110 is equal to 270 minus 3M. So from this we get 5M equal to 270 plus 110, 380. So M is 76. Therefore, price of mixed variety is rupees 76 per kg. So this is the price of mixed variety. Moving on to the next question. A shopkeeper has 1 quintal of wheat, part of which she sells at 18% gain and the rest at 28% gain. In total, she gains 24%. Find the quantity of wheat sold at 18% and 28%. So here the shopkeeper has 1 quintal of wheat and the cheaper quantity is sold at 18% gain. So C is 18%. The dearer quantity, it is sold at 28% gain. In total, the gain is 24%. We need to find the quantity of wheat that is sold at 18% and 28%. So using this cross, here we have D minus M, which is 4%, and here we have M minus C, which is 24% minus 18%. So it is 6%. So cheaper quantity is to dearer quantity. It is D minus M is to M minus C, which is 4% is to 6%, or it is 4 by 100 is to 6 by 100, which is 2 is to 3. So the quantity of wheat which is sold at 18%, it is 2 by 2 plus 3, which is 5 into 100. So this is 40 kg. Then the quantity of wheat sold at 28% is 3 by 2 plus 3, which is 3 by 5 into 100, which is 60 kg. So this much is the quantity of wheat sold at 8% and this much is the quantity of wheat sold at 28%. Let us move on. The next question. 600 gram of jaggery syrup has 40% jaggery in it. How much jaggery should be added to make it 50% in the syrup? So here 600 grams of jaggery syrup, there is 40% jaggery in it. We need to find the quantity of 100% pure jaggery that should be added so that the syrup has 50% jaggery. So here jaggery syrup, the quantity is 40%. We are adding pure jaggery. So it has 100% jaggery in it. We need to have a jaggery syrup which has 50% jaggery in it. So the mean percentage is 50%. C is 40, D is 100 and M is 50. So here we have D minus M. 100% minus 50% is 50%, and here we have M minus C. 50% minus 40% is 10%. So using this, the ratio of jaggery syrup to jaggery, it is jaggery syrup is to jaggery. It is 50% is to 10%. So it is 50 by 100 is to 10 by 100, or it is 5 is to 1. So for every 5 grams of jaggery syrup, we have to add 1 gram pure jaggery. So for 600 grams of jaggery syrup, we have to add 600 by 5 into 1 jaggery. So this is 120 grams. So the required quantity of jaggery to be added is 120 grams. So here also we can use the rule of alligation and we can find the answer. Again, questions on alligation and mixture can be expected in MCQ for 1 mark, or if it is asked as a direct question, it can come for 2 marks. Next question, in what ratio water must be added to dilute honey costing rupees 240 per liter so that the resulted syrup would be worth rupees 200 per liter. So we need to find the ratio in which we have to add water to honey so that the resulting syrup will be worth rupees 200 per liter. So here the cheaper quantity is water and the cost is 0 rupees. Here the dearer quantity is honey and the cost is rupees 240 per liter. We need to get a resulted syrup whose price is rupees 200 per liter. So the ratio of water is to honey can be calculated as D minus M upon M minus C. So this side we have D minus M, it is 240 minus 240, and here we have M minus C, it is 200 minus 0, which is 200. So the ratio of water to honey, it is D minus M is to M minus C, which is 40 is to 200, or this is 1 is to 5. So the ratio in which water must be added to honey is 1 is to 5. This is the required ratio. The last question in this exercise, a container has 50 liters of juice in it. 5 liters of juice is taken out and is replaced by 5 liters of water. This process is repeated 4 more times. What is the amount of juice in the container left after replacement, after final replacement? So this is very easy here. The original quantity of the quantity of original liquid is 50 liters. Then quantity which is taken out and replaced with water is 5 liters. And N is the number of times this process is repeated. First it is done and it is repeated 4 more times. So N will be 4 plus 1, 5. So amount of juice left will be the formula is x into 1 minus y by x the whole raised to n. So it is 50 into 1 minus 5 by 50 the whole raised to 5. So it is 50 into, here since we are having whole raised to 5, let us have this as 1 minus 0.1, which is 0.9 the whole raised to 5. We can either use log tables, or if the value is given in the question, we can use it. So the value is 50 into 0.5905. So this is 29.525, or it is approximately equal to 29.5 liters. So these are the various questions given on alligation and mixture from Chapter 1 Numbers, Quantification and Numerical Applications in the CBSE Handbook. Now let us start with the next exercise, which is exercise 4. The questions on this exercise are on the topic problems on boats and streams. The first question, find the speed of the boat if a boat moves downstream at the rate of 16 km per hour and upstream at the rate of 10 km per hour. Now we are familiar with the various notations that are used in boats and streams. The speed of the boat, it is denoted by x km per hour. The downstream speed is given by u km per hour and the upstream speed is given by v km per hour. So we have to find x when u and v are given. So here the downstream speed is given as 16 km per hour. The upstream speed is 10 km per hour. Now we are familiar with the formula. The speed of the boat is given by u plus v by 2. So it is 16 plus 10 by 2, which is 26 by 2, 13. So speed of the boat is 13 km per hour. So this is the answer. Moving on to the next question. The speed of a boat in still water is 14 km per hour. While going downstream, it moves at the rate of 24 km per hour. Find the speed of the boat against the stream. So here the speed of the boat in still water is given, that is x is given, it is 14 km per hour. And then the downstream speed is given, u is given. It is 24 km per hour. We have to find the speed of the boat against the stream, that is we have to find v. So u is nothing but x plus y, where y is the speed of stream. So this implies 24 is equal to 14 plus y, or y is equal to 10 km per hour. Therefore, v is equal to x minus y. So it is 14 minus 10, which is 4 km per hour. Therefore, speed of boat upstream it is equal to 4 km per hour. So this is what we have to find. Speed of the boat against the stream, it is 4 km per hour. Next question. A boat goes 8 km upstream and then returns. Total time taken is 4 hours 16 minutes. If the speed of the current is 1 km per hour, find the actual speed of the boat. So here the distance which a boat travels upstream and then downstream, it is given, it is equal, which is 8 km. The total time taken is given, which is 4 hours 16 minutes. The speed of the current is given. We have to find the speed of the boat. So let us take, let speed of the boat be x km per hour. This distance it is given as 8 km and the speed of the current is given as 1 km per hour. The total time taken, that is the time taken to go upstream plus the time taken to go downstream, it is the total time, it is given as 4 hours 16 minutes. Time taken to go upstream, it is the distance upon upstream speed, which is x minus y, plus time taken to go downstream is the distance upon downstream speed, which is x plus y. This is equal to the total time 4 hours 16 minutes. 4 hours 16 minutes is nothing but 4 plus 16 by 60. So it is 64 by 15. So the total time is 64 by 15. So let us take d outside and here the LCM is x minus y into x plus y, which is x square minus y square. So numerator will have x plus y plus x minus y. This is equal to 64 by 15. D we know it is given as 8. So 8 into 2x upon x square minus y is given as 1 minus 1 equal to 64 by 15. So from this we get here 8 8s are 64, then again 4. So let us cross multiply. 15x is equal to 4x square minus 4. Or from this we get 4x square minus 15x minus 4 equal to 0. So this is a quadratic equation in x. We can solve this. So here we have minus 16x plus x minus 4 equal to 0. So this is 4x into x minus 4 plus 1 into x minus 4. Or the factors are 4x plus 1 and x minus 4. So from this we get x is equal to 4 or x is equal to negative 1 by 4. So we cannot have negative 1 by 4. So the speed of the boat in still water is 4 km per hour. Therefore, speed of boat equal to 4 km per hour. If we are very familiar with the formula and if this question is asked in MCQ, we can use the formula D is equal to T into x square minus y square upon 2x. We can use this formula directly if we remember the formula well and if it is asked in an MCQ. If it is asked in 2 mark question and if there are marks for steps, then we have to proceed with the steps. Next question, a man can row 7 km per hour in still water. If the stream is flowing at the rate of 5 km per hour, it takes him 7 hours to row to a place and return. How far is the place? So here we have to find the distance of the place. So here let the distance of the place be d kilometer. The speed of the person in still water it is 7 km per hour. And then the speed of the stream is 5 km per hour. And then the total time taken to row to a place and return, it is 7 hours. So we have to find D. If we are familiar with the formula, D is equal to T into x square minus y square upon 2x. If we substitute the values for T, x and y, we will get the value for D. Otherwise, we can proceed like this. The time taken upstream, it is d by x minus y plus time taken downstream is d by x plus y. This is equal to the total time which is 7. So d into, here we have the numerator x plus y plus x minus y upon denominator is x minus y into x plus y, which is x square minus y square. This is equal to 7. So d is equal to 7 into x square minus y square. This is x plus x 2x. It will go in the denominator. So we are getting the same formula. So d is 7 into x is 7 square minus y is 5 square upon 2 into 7. So these two 7 will cancel. Here it is 7 square is 49 minus 5 square is 25 upon 2. This is 24 by 2, which is 12. Therefore, D is equal to 12 kilometers. So the distance of the place is 12 kilometers. The next question, a boat covers 32 km upstream and 36 km downstream in 7 hours. Also, it covers 40 km upstream and 48 km downstream in 9 hours. Find the speed of the boat in still water and that of the stream. So here we are given two situations. Using these two situations, we have to solve the equations and find the answer for x and y. So let us take let x and y be the speed of the boat in still water and speed of the stream respectively. So first it is given boat covers 32 km upstream and 36 km downstream in 7 hours. So the time taken to cover 32 km upstream is 32 upon x minus y plus the time taken to cover 36 km downstream is 36 upon x plus y. This is equal to 7. Similarly here the time taken to cover 40 km upstream is 40 upon x minus y and time taken to cover 48 km downstream is 48 upon x plus y. This total time, it is equal to 9. So let us take this as the first equation. So if we solve these two equations, we can find x and y. We cannot directly solve these two equations. So let us make the substitution. Let 1 by x minus y equal to p and 1 by x plus y equal to q. Let us take this as 2. So the first equation becomes 32p plus 36q equal to 7. Then 40p plus 48q equal to 9. Now let us solve these two equations. Let us multiply this equation by 5 and this equation by 4. So here we get 160p plus 180q equal to 35 and here 160p plus 192q equal to 36. So if we subtract, we get negative 12q equal to negative 1. So from this we get q is equal to 1 by 12. So let us take this as 3 and this as 4. So from 3, if we substitute q as 1 by 12 in 3, we can find p. 32p plus 36 into 1 by 12 equal to 7. So 32p equal to 4 or p is 4 by 32 which is 1 by 8. So we got p as 1 by 8 and q as 1 by 12. Now these values of p and q we can substitute in 2. From 2, 1 by x minus y equal to 1 by 8. So from this we get x minus y as 8. Then 1 by x plus y equal to 1 by 12. From this we get x plus y as 12. Now it is easy to solve these two equations. X will be 8 plus 12 by 2. It is 20 by 2 which is 10. And y will be 12 minus 8 by 2. It is 4 by 2 which is 2. Therefore the speed of the boat in still water is 10 km per hour and speed of the stream is 2 km per hour. Therefore speed of boat equal to 10 km per hour and speed of stream equal to 2 km per hour. So we are asked to find the speed of the boat in still water and speed of stream. So these are the values. Let us proceed. Next question. A man can row 7.5 km per hour in still water. If in a river running at 1.5 km per hour, it takes him 50 minutes to row to a place and come back. How far off is the place? So here the speed of the person in still water is given, the speed of the river is given, and the total time taken to row to a place and come back is given. We need to find the distance of the place. So let us take, let the distance of the place be d kilometers. Then the speed of the man in still water is 7.5 kilometers per hour. So x is 7.5. It is nothing but 15/2 kilometers per hour. Then y is, the speed of the river is 1.5 kilometers per hour. 1.5 is nothing but 1.5. It is 3/2 kilometers per hour. So time taken to go upstream plus time taken to go downstream, it is the total time. Again we can use the formula directly. D is equal to T into x square minus y square upon 2x if step marks are not required. Otherwise, let us proceed with the steps. Time taken upstream is d upon x minus y plus time taken downstream is d upon x plus y. This is equal to the total time, which is 50 minutes. 50 minutes is nothing but 50/60 hours. So this is 5/6. So d into x plus y plus x minus y upon LCM is x square minus y square equal to 5/6. D into 2x upon x square minus y square is 5/6. So from this d is 5/6 into x square minus y square upon 2x. So from this we can find d. D is 5/6 into x is 15/2 and y is 3/2. 15/2 the whole square minus 3/2 the whole square upon 2 into x is 15/2. So this is 5/6 into 15 into 15/2 the whole square is 225/4 minus 3/2 the whole square is 9/4. So this is 1/6 into 3 into 225 minus 9 is 216/4. So if we simplify, we get d as 3 kilometers. So the place is 3 kilometers far. Next question. The speed of a motorboat and that of the current of water is 36:5. The boat goes along with the current in 5 hours 10 minutes. How much time will it take to come back? So here the ratio of the speed of the boat and that of the current is given. It is 36:5. Then the time taken to go downstream is given 5 hours 10 minutes. We need to find the time it will take to come back. So let T2 be the time taken to return. And here it is given x is to y is 36:5. So from this we get x by y as 36/5. Now the distance travelled upstream equal to the distance travelled downstream. Here we are taking T2 as the time taken upstream. So let us take T1 as the time taken to go downstream, which is 5 hours 10 minutes. Or it is 5 plus 10/60 hours. So it is 31/6 hours. Now we know that the distance travelled upstream is equal to the distance travelled downstream. Distance travelled upstream is the time taken to go upstream into the upstream speed. This is equal to the time taken to go downstream into the downstream speed. This implies T2 is equal to T1 into x plus y upon x minus y. Now we have x by y as 36/5. So using componendo and dividendo, if x plus y equal to 36 by 5, then x plus y upon x minus y will be 36 by 5 upon 36 minus 5. So using this property, here we can substitute the values for x plus y upon x minus y. T1 is 31 by 6. So if we substitute all these values, we will get the answer for T2. So this is 31 by 6 into 36 plus 5 upon 36 minus 5. This implies T2 is equal to 31 upon 6 into 41 by 31. So these two will go. So T2 is 41 by 6 hours. Now this 41 by 6, it is nothing but 6 5 by 6 hours. Now this 5 by 6 is 5 by 6 into 60 minutes. So it is 50 minutes. So this is 6 hours, 50 minutes. Therefore, time taken to return is 6 hours, 50 minutes. So these are the various questions from exercise 4 on boards and streams from the CBSE Handbook. Now let us move on to the next exercise, which is the 5th exercise. The questions here are on problems on pipes and cisterns. The first question, it is given pipe A can fill a tank in 3 hours and pipe B in 45 hours. If both the pipes are opened in an empty tank, how much time will it take to fill the tank? So this is a very simple question. A takes 30 hours to fill the tank and B takes 45 hours to fill the tank. If both pipes are opened in an empty tank, we need to find the time in which they will fill the tank. So here it is given A takes 30 hours to fill the tank. So the part of the tank which is filled by A in 1 hour, it will be 1 by 30. And then it is given pipe B takes 45 hours to fill the tank. So part of the tank filled by pipe B in 1 hour, it will be 1 by 45. So the part of the tank which is filled by both the pipes in 1 hour, it will be the sum of these two, 1 by 30 plus 1 by 45. LCM is 90. So this is 5 by 90, or it is 1 by 18. So the time taken to fill the tank will be the reciprocal of this. That is, it will be 1 by 18, which is 80. So time taken to fill the tank is 18 hours. Moving on to the next question. A pipe can fill a cistern in 6 hours. Due to a leakage in the tank, the cistern is just full in 9 hours. How much time the leakage will take to empty the tank? So here the time taken to fill a cistern by a pipe is given, it is 6 hours, and because of the leakage the tank is full in 9 hours. We need to find the time taken by leakage to empty the tank. So let us take the time taken by leakage to empty the tank be T hours. So part filled by the pipe in 1 hour, it will be 1 by 6. And then the part emptied by leakage in 1 hour, it is 1 by T. Now the part of the tank which is filled because of the pipe and leakage in 1 hour, it is 1 by 9. Because here it is given because of the leakage, the cistern is full in 9 hours. So the part filled in 1 hour will be 1 by 9. But this 1 by 9, it is nothing but 1 by 6 minus 1 by T. This is equal to 1 by 9. So it is the work done by the pipe and leakage in 1 hour. So it is 1 by 6 minus 1 by T. This is equal to 1 by 9. So from this we can find T. This implies 1 by T equal to 1 by 6 minus 1 by 9. Here the LCM is 18. So 1 by T is 1 by 18. or T is 18. So we have taken T as the time taken by leakage to empty the tank. Therefore, the time taken by leakage to empty the tank will be 18 hours. Moving on to the next question. A cistern can be filled by pipes A and B in 4 hours and 6 hours respectively. When full, the cistern can be emptied by pipe C in 8 hours. If all the pipes were turned on at the same time, in how much time will the cistern be filled? So this is also very easy. We just have to find 1 by 4 plus 1 by 6 minus 1 by 8. This is the part which is filled in 1 hour. So if we take the reciprocal of this, we will get the answer. So part filled in 1 hour when all the pipes are opened, it is given by 1 by 4 plus 1 by 6 minus 1 by 8. So here the LCM is 24. 6 plus 4 minus 3. This is 7 by 24. So time taken to fill the cistern, it will be 24 by 7 hours. That is the reciprocal of this. This 24 by 7, it is nothing but it is 3 by 7 hours. This 3 by 7 hour is 3 by 7 into 60 minutes, or it is approximately equal to 25. So this is 3 hours 25 minutes, approximately equal to. Moving on to the next question. A cistern can be filled in 8 hours, but due to leakage in its bottom, it takes 2 hours more to fill the tank. If the cistern is full, how much time will the leakage take to empty it? So here the cistern can be filled in 8 hours, but because of the leakage, it takes 2 hours more to fill the tank. When the cistern is full, we need to find the time taken for leakage to empty the tank. So let the leakage take T hours to empty the cistern. So part filled by the pipe in 1 hour will be, here it is given a cistern can be filled in 8 hours. So part filled in 1 hour will be 1 by 8. And then the time taken to fill the cistern because of the leakages, it takes 2 hours more. So the time taken is 8 plus 2, which is 10 hours. So the part of the tank which is filled because of leakage in 1 hour, it will be 1 by 10. Now this 1 by 10, it is nothing but the part filled in 1 hour minus the part emptied in 1 hour, which is 1 by t. So 1 by 8 minus 1 by t, it is equal to 1 by 10. So from this we get 1 by t as 1 by 8 minus 1 by 10. Here the LCM is 40. So it is 1 by 40. So we get 1 by t as 1 by 40. So t is equal to 40. So the time taken by leakage to empty the tank, it is 40 hours. This is 40 hours. Next question. A cistern can be filled by an inlet pipe in 20 hours and can be emptied by an outlet pipe in 25 hours. Both the pipes are opened. After 10 hours, the outlet pipe is closed. Find the total time taken to fill the tank. So here we have an inlet pipe which can fill the cistern in 20 hours and an outlet pipe which can empty the cistern in 25 hours. Initially both the pipes are opened and after 10 hours the outlet pipe is closed. We need to find the time taken to fill the tank. So let T be the total time taken to fill the tank. In this case, the inlet pipe is open for the entire time, which is T hours, and the outlet pipe is open for only 10 hours. Because here it is given after 10 hours, the outlet pipe is closed. So the outlet pipe is open for this 10 hours. So here the work done by inlet pipe in T hours plus the work done by the outlet pipe in 10 hours will be the entire work. Here we have The inlet pipe fills the cistern in 20 hours. So the part of the cistern filled by inlet pipe in 1 hour will be 1 by 20. The part of the cistern filled by inlet pipe in T hours will be T by 20. Similarly, the part of the cistern emptied by the outlet pipe in 1 hour will be 1 by 25. The part emptied in 10 hours will be 10 by 25. So T by 20 minus 10 by 25 will be the entire tank. So here the LCM is 100. So 5T minus 40 equal to 1, or 5T equal to 5T minus 40 equal to 100. From this we get 5T as 140, or T is equal to 140 by 5, which is 28. So time taken to fill the tank is 28 hours. So this is the total time taken to fill the tank. So it is better to take whatever is asked in the question as T. Moving on to the next question. Two pipes A and B can fill a tank in 24 minutes and 32 minutes respectively. If both the pipes are opened simultaneously, after how much time B should be closed so that the tank is full in 18 minutes? So here we have two pipes A and B which can fill the tank in 24 minutes and 32 minutes respectively. We need to find the time after which B should be closed so that the tank is full in 18 minutes. So here let us take, let B be closed after time T. So if B is closed after time T, the meaning is that B is open for T minutes and A is open for the entire 18 minutes. A is open for 18 minutes. Now here it is given A can fill the tank in 24 minutes. So part of the tank filled by A in 1 minute will be 1 by 24, and part of the tank filled by B in 1 minute will be 1 by 32. So part of the tank filled by A in 18 minutes will be 18 by 24, plus part of the tank filled by B in T minutes will be T by 32. Now this will be equal to the entire tank. So here the LCM is 96. So this is 24 into 4 is 96. So 18 into 4 is 72, plus here 32 into 3 is 96. So here we have 3T equal to 1. So from this we get 72 plus 3T equal to 96, or 3T equal to 96 minus 72, which is 24. So T is 8. Therefore B should be closed after 8 minutes. B should be closed after 8 minutes. If B is closed after 8 minutes, the tank will be full in 18 minutes. Moving on to the last question in this exercise. A tank is fitted with 3 taps A, B and C. All the 3 taps, if opened together, can drain the full tank in 1.5 minutes. Taps B and C together take 2 minutes to drain the tank, while A and C together take 4 by 13 minutes to drain it. How long will taps A and B together take to drain the tank? So here we have 3 pipes A, B and C, and when all the pipes are open, it will drain the entire tank in 1.5 minutes. B and C alone can drain in 2 minutes. Then A and C alone can drain in 4 by 3 minutes. We need to find the time in which A and B together can drain the tank. So here let us take, let T1 and T2 be the time taken by tap A and tap B to drain the tank respectively. Here it is given A, B and C together can drain the full tank in 1.5 minutes. Now this 1.5, it is nothing but it is 3 by 2. So the part of the tank which is drained by A, B and C together in 1 minute will be the reciprocal of this, which is 2 by 3. Let us take this as 1. Then taps B and C together take 2 minutes to drain the tank. So the part drained by B and C together in 1 minute will be half. So from 1 and 2 we can see that the part drained by A, B and C together in 1 minute, it will be half plus 1 by T1, because we have taken, let T1 be the time taken by tap A to drain the tank. So the part drained by A, B and C together will be the part drained by A in 1 minute plus the part drained by B and C together in 1 minute, which is 1 by T1 plus half. This is equal to 2 by 3. So from this we can find 1 by T1 as 2 by 3 minus half. It is 4 minus 3 by 6, which is 1 by 6. So we get 1 by T1 equal to 1 by 6. So T1 will be equal to 6. T1 equal to 6 minutes. So we found the time taken by tap A to drain the tank. And next we have the next information. The part drained by A and C together in 1 minute will be, here it is given A and C together take 2 4 by 13 minutes to drain it. So 2 4 by 13 is, it is nothing but 30 by 13. So part drained by A and C together in 1 minute will be the reciprocal of this, which is 13 by 30. Let us take this as 3. So from 1 and 3, part drained by A, B and C together is 2 by 3. But A and C is 13 by 30. So we have 13 by 30 plus 1 by T2, which is part drained by B in 1 minute. This is equal to 2 by 3. 1 and 3 implies. So from this we can find T2. T2, 1 by T2 is 2 by 3 minus 13 by 30. Here the LCM is 30. So here we have 20 minus 13 by 30, which is 7 by 30. So from this we get this T2 as, it is 30 by 7. So part drained by A and B together will be 1 by T1 plus 1 by T2. This is 1 by 6 plus 7 by 30. Or here again the LCM is 30. So here we have 5 plus 7 by 30. This is 12 by 30. Or it is 2 by 5. Therefore, A and B together can drain the tank in 5 by 2 minutes. 5 by 2 is, it is nothing but 5 by 2 is 2.5. So it is 2 minutes 30 seconds. So this is the time in which A and B together can drain the tank. So these are the questions from exercise 5, which are on problems on pipes and cisterns. Now we have the next exercise, which is exercise 6. The questions from this exercise are on the topic problems on races and games. The first question, in a 1000 meters race, A defeats B by 300 meters and B defeats C by 200 meters. In the same race, by how many meters will A defeat C? So here it is given the race is for 1000 meters and A defeats B by 300 meters. The meaning is that if A runs 1000 meters, B will run 1000 minus 300, which is 700 meters. Similarly, here B defeats C by 200 meters. The meaning is that if B runs 1000 meters, then C will run 1000 minus 200, which is 800 meters. Now we need to find the distance by which A will defeat C. So here we have A defeats B by 300 meters. So if A runs the entire 1000 meters, B will run 1000 minus 300, which is 700 meters in the same time. As a result, we can find the ratio of the speed of A to B. So speed of A is to B, it is 1000 is to 700, or it is 10 is to 7. Similarly, we can find the ratio of speed of B is to C, and from that we can find the ratio of speed of A is to B is to C, which will be helpful to find the answer. So here B defeats C by 200 meters means the ratio of speed of B to C, it is 1000 is to 1000 minus 200, which is 800. So this is 10 is to 8. So this is 10 by 7 and this is 10 by 8. Now we need to have the ratio of A is to B is to C. So here we have B as common. So to get A is to B is to C, we need to have this term common. So what we can do is, here let us multiply and divide by 10, and here let us multiply and divide by 7. So that we have the same LCM for 7 and 10, which is 70. So this is nothing but 100 is to 70, and this is nothing but 70 is to 56. So A is to B is to C will be 100 is to 70 is to 56. So this is the ratio of their speeds. So now we have the ratio for A is to C. So from this, A is to C is 100 is to 56. So here A travels 100 meters and in the same time C travels 56 meters. Therefore, when A travels 1000 meters, in the same time C will travel 560 meters. Thus, A beats C by 1000 minus 560. It is equal to 440 meters. So, this is the answer. So, A will defeat C by 440 meters. Next question, in a 1000 meters race, A can give a start of 100 meters to B and a start of 280 meters to C. In the same race, how much start can B give to C? So here A can give B a start of 100 meters means when A starts from the beginning point, B will start 100 meters ahead of A. So if A has to run the entire 1000 meters, B will start the race 100 meters ahead of A. This is 100 meters. So that B has to cover only 1000 minus 100, which is 900 meters. So from this we can find the speed of A is to B. It is 1000 is to 1000 minus 100, which is 900. So here this let us write it as 100 is to 90, because we need to have the ratio of A is to B is to C. The next information which is given is A can give a start of 280 meters to C. So the meaning is that when A starts from the beginning, that is when A has to run 1000 meters, C has to run only 1000 minus 280 meters. 1000 minus 280, it is 720. So as a result, speed of A is to C, it is 1000 is to 720, or it is 100 is to 72. So we can combine these two. Therefore, A is to B is to C, it is 100 is to 90 is to 72. Here we need to find how much start can B give to C. So let us take the ratio of B to C alone. So from this we get B is to C as 90 is to 72, or it is 10 is to 8. So when B can run this 10 meters, then C runs 8 meters. B travels 10 meters and in the same time C travels 8 meters. Therefore, when B travels 1000 meters, in the same time C travels 800 meters. So B can give C a start of 1000 minus 800, which is 200 meters. So here we are asked to find how much start can B give to C. B can give C a start of 200 meters. Moving on to the next question. In a 500 meters race, A defeats B by 60 meters or 12 seconds. What is the time taken by A to complete the race? So here it is given A defeats B by 60 meters or 12 seconds. So the distance by which A defeats B and the time by which A defeats B is given. So from this we can find the speed of B and then we can find the time taken by A to complete the race. So speed of B will be 60 by 12, which is 5 meters per second. So the speed of B is 5 meters per second. The time taken by B will be distance by speed. So it is 500 by 5, which is 100 seconds. Here it is given A defeats B by 12 seconds. As a result, time taken by A will be 100 minus 12. 100 minus 12, which is 88 seconds. So this is the time taken by A to complete the race. Next question. In a 900 meters race, A gives B a start of 150 meters and defeats him by 50 seconds. If speed of A is 4.5 meters per second, then find the speed of B. So here it is given the distance by which A gives B a start is given, it is 150 meters and the time by which A defeats B is given, it is 50 meters. If the speed of A is 4.5 meters per second, we need to find the speed of B. So here the time taken by A, it will be distance by speed. So it is 900 upon 4.5 or it is 9000 by 45, which is 200 seconds. So time taken by A is 200 seconds. Time taken by B will be, here it is given, A defeats B by 50 seconds. So B will take additional 50 seconds to complete the race. Time taken by B will be 200 plus 50, which is 250 seconds. And then here it is given A gives B a start of 150 meters. So the distance covered by B, it will be 900 minus 150, which is 750 meters. So speed of B will be distance covered by B upon time taken by B. So it is 750 upon 250. This is 3 meters per second. So this is the speed of B. Moving on to the next question. A runs 3 times as fast as B. If A gives B a start of 40 meters, how far must the goal on the race course be so that A and B reach the goal at the same time? So here the ratio of speed of A to B is given and then A gives B a start of 40 meters. We need to find the length of race course so that A and B reach the goal at the same time. So here given speed of A is 2, speed of B is 3:1. A runs 3 times as fast as B. So speed of A is to speed of B is 3:1. So let speed of A and B be 3x and x. And let total distance be d meters. So the time taken by A to cover d meters, it is equal to time taken by B to cover d minus 40 meters because A gives B a start of 40 meters. So time taken by A to cover d meters, it is nothing but distance by speed. So it is d by 3x. This is equal to time taken by B to cover d minus 40 meters. So here it is distance by speed of B. Speed of B is x. So from this we can find d. D equal to 3d minus 120 or 120 equal to 2d. Therefore, d is 120 by 2, which is 60 meters. So, the length of the race course is 60 meters. Next question. A team played 40 games in a season and lost in 16 of them. What percent of games played did the team win? So here the number of games played is given, the number of games lost is given. So from that we can find number of games won. Number of games won is 40 minus 16. So it is 24. We are asked to find the percentage of games played, the team won. So percentage of winning is number of games won divided by total number of games into 100. So this, when we simplify, we get it as 60%. So this is the percentage of winning. Next question. In a 200 meters race, Pratik beats Samarth by 35 meters or 7 seconds. How much time did Pratik take to cover the race? So here it is similar to the question which we saw previously. It is given Pratik beats Samarth by 35 meters or 7 seconds. So from this we can find the speed of Samarth, and from that we can find the time taken by Pratik to cover the race. So speed of Samarth is 35 by 7, which is 5 meters per second. So using the speed of Samarth and the distance, we have the time taken by Samarth. It is distance by speed, which is 200 by 5, 40 seconds. So if Samarth takes 40 seconds, here it is given Pratik beats Samarth by 7 seconds. So time taken by Pratik will be 40 minus 7, which is 33 seconds. So these are the various questions on races and games from exercise 6. Let us move on to the next exercise, which is the exercise on numerical inequalities. The first question. Mr. X and Mr. Y have net worth of rupees 1.93 crores of Indian rupees and negative 0.22 crores of Indian rupees. Represent the above information in the form of inequality. So here the simple term is that 1.93 is greater than negative 0.22, or net worth of Mr. X greater than net worth of Mr. Y. So this is the answer. Next question. Two players, player A and B, are playing a game by rolling a dice. They decided that the player who will get the higher total will be the winner. In total, they roll the dice 3 times and the observations are recorded as follows. Now we have to answer these questions. So these are the points obtained by each player for each throw of a die. So they have threw 3 times. Who is the winner of the game? So here the total points scored by player A is 8 and this is 11. So the winner of the game is player B. We have to represent the above information as a numerical inequality. So here 8 is less than 11. Since 8 is less than 11, the person who got the higher score will win the game. B got 11, so B won the game. Next question, solve 4x minus 2 less than 8 when x belongs to z. Z is the set of integers. So here 4x minus 2 less than 8. It is 4x less than 8 plus 2, 10. So x will be less than this 10 by 4. So from this we get x less than 2.5. Since x belongs to the set z of integers, we have to have all those integers less than 2.5. So those integers less than 2.5 are 2, 1, 0, then -1, -2, -3, so on till negative infinity. So this is x. Here since x belongs to the set z of integers, we have x less than 2.5. So we have all those integers less than 2.5. So it is 2, 1, 0, -1, -2, -3 up to etc. Next question, show that the numbers 16 and 14 satisfy the numerical inequality arithmetic mean greater than geometric mean. So here A is 16 and B is 4. Arithmetic mean is A plus B by 2. So it is 16 plus 4 by 2. 20 by 2 which is 10. And the geometric mean is square root of AB. It is square root of 16 into 4. It is 4 into 2 which is 8. So we get 10 greater than 8 or arithmetic mean greater than or equal to geometric mean. Next question, solve the following inequality. We have negative 2z minus 6 less than 10. Now let us multiply both sides by negative 1. If we multiply both sides by negative 1, the direction of inequality changes. So we get 2z plus 6. It is greater than negative 10. So from this we get 2z greater than negative 10, negative 6, or 2z greater than negative 16, or z greater than negative 8. So this is the solution. Z greater than negative 8, or z belongs to the open interval negative 8 comma infinity. Next question, 2a less than a minus 4 less than or equal to 3a plus 8. So when we have such type of inequalities, let us solve the inequalities separately. First let us take 2a less than a minus 4 and then let us solve a minus 4 less than or equal to 3a plus 8, and later on let us combine these two. So from this we get 2a minus a less than negative 4, and from here we have negative 4 less than or equal to 3a minus a plus 8. So if we transpose this plus a to the other side, we get minus 8. So minus 4 minus 8 is less than or equal to 2a, or minus 12 less than or equal to 2a, or minus 6 less than or equal to a. So if we combine 1 and 2, 1 and 2 implies minus 6 less than or equal to a less than minus 4. So here a belongs to the closed negative 6, open negative 4. So this is the solution for this inequality. Next question, y minus 1 by 3 plus 4 less than y minus 5 by 5 minus 2. So here let us collect all the terms with y on one side and the constant term on other side. So we get y minus 1 by 3 minus y minus 5 by 5 less than minus 2 minus 4. So here LCM is 15. Here we have 5y minus 5 minus 3y plus 15 upon 15 less than negative 6. So here we have 2y plus 10 less than 5y minus 3y is 2y minus 5 plus 15 is plus 10 less than, here if we cross multiply we get 15 into minus 6 which is minus 90. So from this we get 2y less than negative 90 minus 90 minus 10 which is minus 100, or we have y less than minus 50. Therefore, y belongs to the open interval minus infinity comma minus 50. So this is the solution for this inequation. Next question, prove that the following inequality holds true. So here we have to prove that root 5 plus root 3 greater than root 6 plus root 2. So to prove root 5 plus root 3 greater than root 6 plus root 2, or let us have it as root 3 minus root 2 greater than root 6 minus root 5. It is the same. So let us prove this. First let us consider root 6 minus root 5. This root 6 minus root 5, we can write it as root 6 minus root 5 into root 6 plus root 5 upon root 6 plus root 5. Multiplying and dividing by root 6 plus root 5. So here it is of the form a minus b into a plus b. It is a square minus b square. So it is root 6 the whole square minus root 5 the whole square upon root 6 plus root 5. So here square and root will go. Here we will have 1 by root 6 plus root 5. Let us take this as 1. And next let us consider root 3 minus root 2. This is equal to root 3 minus root 2. Let us multiply and divide by root 3 plus root 2. So here again we will have root 3 the whole square minus root 2 the whole square, which is 3 minus 2, 1 upon root 3 plus root 2. So let us take this as 2. Now root 6 plus root 5 is greater than root 3 plus root 2. This is obvious. Root 6 plus root 5, it is greater than root 3 plus root 2. So from this 1 by root 6 plus root 5 is less than 1 by root 3 plus root 2. This is by the property of inequality. Now this 1 by root 6 plus root 5 is nothing but this root 6 minus root 5. So this is root 6 minus root 5. This is less than 1 by root 3 plus root 2 is root 3 minus root 2. Root 3 minus root 2. This is from 1 and 2. So from this we get root 6 plus root 2 less than root 5 plus root 3, or root 5 plus root 3 greater than root 6 plus root 2. So this is what we have to prove, and we have proved. Next question. Satyat and Swarit are brothers. Satyat owns a house which is worth rupees 3 crores and Swarit owns a farmhouse which is worth 2.75 crores. But Satyat has a debt of rupees 55 lakhs. If they both sell their properties, then which of the following statements holds true to represent the above data mathematically? So here Satyat owns a house of 3 crores but he has a debt of rupees 55 lakhs. So after the house is sold, the net worth of Satyath, it will be, Satyath net worth will be this 3 crores minus 55 lakhs. 3 crores minus 55 lakhs, it will be 2.45 crores. Then the next information is, if Swarit sells his farmhouse, then the net worth of Swarit will be 2.75 crores. So here the first option is Satya's net worth is more than Swarit's net worth. This is wrong. This is not true. Whereas Swarit's net worth is more than Satya's net worth. This is correct. I think this should be 2.45. And the next option is 2.45 less than 2.75. This is also true. So these two statements are true. Next question, insert the appropriate sign of inequality. So here we have root 3 into root 50 minus root 32, and in the right hand side we have 3 root 54 plus 2 root 24. So first let us take root 3 into root 50 minus root 32. So this is root 3 into root 50, we can write it as 25 into 2, minus root 32 we can write it as 16 into 2. So this 25 is 5 square and this 16 is 4 square. So this is root 3 into 5 root 2 minus 4 root 2. 5 root 2 minus 4 root 2 is root 2. Root 3 into root 2 is root 6. Now let us consider 3 root 54 plus 2 root 24. Left hand side and right hand side. Now 3 root 54, we can write 54 as 9 into 6 plus 2 root 24, we can write it as 4 into 6. So 9 is 3 square and 4 is 2 square. So this is 3 into 3 root 6 plus 2 into 2 root 6. Or this is 9 root 6 plus 4 root 6, which is 13 root 6. So the left hand side the value is root 6 and for right hand side the value is 13 root 6. So the appropriate sign of inequality is less than. This implies root 3 into root 50 minus root 32 is less than 3 root 54 plus 2 root 24. Next question. If a and b are positive integers and a minus b by 6.25 equal to 8 by 2.5, we have to choose which option is correct. So let us try to simplify this. A minus b will be 8 by 2.5 into 6.25. So this is 2.5 here. So from this we get a as b plus 20. So this means here it is given a and b are positive integers. So if we get a as b plus 20, then a will be more than b. So here b is not equal to a, b is not greater than or equal to a, and b is not greater than a. B is less than a. So the correct option is option 2. B is less than a. A greater than b means b is less than a. The last question. If p greater than q and r less than 0, then which of the following is true? So here it is given p is greater than q and r is less than 0. That is r is negative. We have to find which option is true. Now if we take p as 5 and q as 3, if we see, and let us take r as negative 1. Let us see the second option. P minus R will be 5 plus 1 and Q minus R will be 3 plus 1. This is 6, this is 4. 6 is not less than 4. So this option will not hold. Let us see the third option. P plus R will be 5 minus 1, 4 and Q plus R will be 3 minus 1, 2. Again P plus R is not less than Q plus R. But if R is negative and if we multiply by a negative number on both sides, then the direction of inequality changes. So here PR will be less than QR. Here 5 is more than 3, but minus 5 is less than minus 3. So the correct option is option 1, PR less than QR. This we have studied in the properties of numerical inequalities itself. So these are the solution for the first chapter, numbers, quantification and numerical applications. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. Thank you for watching.